Okay, here's a quick reminder how to do inverse normal distribution. So a question might sound something like this. Find z such that 15% of the curve lies to the left of z. Um, this is the standard normal curve. We can tell that because they use the letter z. If it's just a normal distribution, typically we use the variable x. Um, so if it's z, it's standard normal, which means our average, our mu, is 0 and our standard deviation is 1. If it's x, it means that the mean and standard deviation can be any number of things. So because this is using z, it means that the mean is 0 and the standard deviation is 1. So we want 15% of the curve to the left of a certain z value. So again, right here in the middle is going to be 0. So 15% isn't that much of the curve. So we're looking at, maybe this section over here, and we want to figure out where this is. So what we can do is use our calculator. So again, 15%. We're going to go to second vars, and inverse normal is number 3. All right, and we're going to type in the area we want. So in this case, 15%, and our mu is 0. Our sigma, our standard deviation, is 1. And then the calculator will tell us the z value. So negative 1.04, let's say. So negative 1.04. Wow, there we go. Now, that's what we call a left tail case. So we're talking about to the left of a z value. If you get something like this where it says to the right, so again, here's 0. So we're looking for 15% to the right. We have to do that a little differently because the calculator goes this way. So if we want 15% to the right, we actually have to figure out 85% to the left, and that's going to tell us this point right here. I got 85 by doing 100 minus 15. So again, going to our calculator, Vars, choice 3. So this time 0.85, and that's going to give us a z. Now this one happens to be just the positive of that. That's what happens. So it's 1.04. Maybe I should have changed the percentage, but okay. So again, if it's to the right, we call this a right tail case because so we'd have to figure out 1 or 100% minus the percentage. Now, the last one that we might have to do is something like this, where it's 40% in between. So what we're dealing with, again, here's our 0, is we're looking for two values that kind of box in this area. So there's a negative z and a positive z. So we want this to be 40%. So what we're going to do is, if you think about it, if the whole thing's 100%, okay, that means we're leaving off 60%, and we want an equal amount left off on the left and the right. So this 60 that we don't want, we're going to divide in half. Half for the left, half for the right. So 60% divided by 2, we're going to do 30%, and that's going to give us a negative z value. But then, just like you saw with the 15%, the negative z value is going to mirror the positive z value. So by getting the negative, we get the positive as well. But the thing is, again, people often forget to divide the difference by 2. So here's what I'm talking about. So again, inverse normal, right? And we're going to do 30%. So again, we're looking for 40% in between. 100 minus 40 is 60. That's in total being left out. Half of that is 30, so 0.3. So the negative z value is negative 0.52. So negative 0.52. which means that the positive would be 0.52. Right? And the way we kind of know that we're dealing with inverse normal distribution is that they typically give us the amount under the curve that we want to figure out. The practical application is usually with like companies giving a guarantee, and they don't want to go over, let's say, 10% of giving customers back money or something like that. So hopefully this is a good reminder.